how fast can you solve these simultaneous equations? And this time I'm not going to give you more than 5 seconds. Alright, so your time starts now. The time is up. The correct answer is x equal to 0 and y equal to 8 by 7. There it is. X equal to 0, y equal to 8 by 7. The usual way of solving these equations, it's way too time consuming. So I would not at all like to do it the usual way. So I'm just skipping this part. Let's see the fast way of doing it. You must have thought that the coefficients of these two simultaneous equations are much more difficult to multiply with, isn't it? So instead of giving you more time, I gave you just 5 seconds. Now you'll know why. Just look at the ratio of the coefficients of y in both the equations and compare it to the ratio of the constants. Do you see something special? Yes, their ratio is equal, isn't it? 7 1 times is 7, 7 2 times is 14, 8 1 times is 8, 8 2 times is 16. So this is also 1 by 2 and this is also 1 by 2. Whenever this happens, you can immediately put the value of other variable to be equal to 0. Alright, so x equal to 0, as simple as that. So just quickly substitute this value in any of these two equations. So x equal to 0, so 6 times 0 is 0, so this thing becomes 0. Now what is left? 7y equal to 8, so y would be equal to 8 over 7, isn't it? You put the coefficient of y to the other side and it goes to the denominator, so y equal to 8 by 7. That is what your answer is. X equal to 0, y equal to 8 by 7. Tell me, wasn't that fast? Once again, let me repeat. When the ratio of the coefficients of y is equal to the ratio of the constants, then x equal to 0. And using the same logic, if the ratio of the coefficients of x equal to the ratio of the constant, then variable y would be equal to 0. Now you try to solve these. So the first thing that strikes you is that the ratio of coefficients of x is equal to the ratio of constants. So immediately put y equal to 0. Now once you have the value of one variable, finding the other variable is very easy, isn't it? So if you put this value here, so this thing becomes 0, isn't it? So 12x equal to 12, that means 12 times something equal to 12. So obviously 12 times 1 equal to 12, so x equal to 1. Now tell me, isn't that a good technique? At the first glance, if you see that multiplying with these coefficients is a big challenge, isn't it? They are intimidating numbers, but we didn't multiply them. That is the beauty of this technique.